Welcome back, everybody. We're going to look at launchpads, the simple implementation and a slightly more advanced version. Let's start off by creating our own Blueprint Launchpad class. Right-click, Blueprints, Actor, and we'll just name this BP Launchpad. Now, this implementation expects that you're using the player character as the default class. So when you go to Blueprint class, not a pawn, but the character class, there's a lot of built-in resources that come along with that. I'm going to add one of these into the world right here, and then we're going to go edit it. So to start this off, we're going to include three primary components by the time we're done with this. We're going to have a launch pad, the mesh itself. So we'll call this the pad. And let's just scale this to 0.1. And we'll just adjust that so it's sitting on the ground, not in the ground. And then we're going to include with that a trigger that is we're going to use as the detection point for the player. So box collision, call that trigger. And we can just make this a little bit wider. And we'll just put that up so that it's above the base. There you go. And then we're also going to include a target point. So for this, we're just going to use a billboard. You've seen us use a child actor in another version, but here we'll use the billboard as the target. So changing the billboard. And you can use what it comes with the default sprite for this, but you can use whatever billboard is most appropriate for your project, custom one, or some of the other ones that are built into the engine. But this will work just fine for us. So for this to work, we're going to have this trigger detect the player on overlap. So we're going to start off by getting the trigger selected, and we're going to right-click. We're going to add an event for the collision on begin overlap, and we're just going to check for the character specifically. And if the character is there, it doesn't have to be our character, but any character, then I can run the code launch character. So launch character has a few different inputs. There's the launch velocity, which is a 3 vector that will tell us in what direction that this is going to launch, and the magnitude that we're going to launch. And then we have the options for override XY or override Z. If we override XY or Z, it will cancel the velocity the player has in that direction before applying this. If you don't override, then it's going to compound that. So for instance, if I had a Z only launch distance, we'll say 420 is the default player jump height. So if I go to play this, then I walk over this, that's how high it bounces me, and that's how high I jump. You can see they're almost identical. The other one just has like an extra, 10 units above the ground. So if that's how high it is, that's on a regular bounce. But this Z override isn't on, and just for demonstrative purposes, I'm going to make this a little bit easier for me to hit. I'll bring it up here, and if I jump up into this, you can see that it catapults me. It adds that force on top of my jump force, and so I go much higher. If I switch that back to having a Z override, then even if I do catch that keen jump, it's just going to bounce me in midair. And it can work against you as well if you don't have the Z override on and you go to hit the launch pad while you're falling down, it barely hops you. So Z override and XY override are going to give you more control over where the player is going to launch. This can be something you do as a one-time if you wanted to use like a collapsible spring or something that can be activated. But we're going to implement something here that will allow you to use it to allow for more compound platforming to allow us to get to a target with a specific jump. So this is going to require that we have X, Y, and Z overrides. We're going to get the player character location when this happens. So we'll get this get location. And then we're also going to get the target location. So here, get world location. So the actual location is for the player, and the world location is for the target that we're going to have. This is going to be for the component that we're going to move this somewhere in the world. There's some math I'm going to show you here. If you don't understand the math, that's fine. You're welcome to copy it. Just be mindful that If you have different expectations of how your jump pads work in your game, you can go a little bit more simulation if you want to get a more high fidelity Newtonian physics on this. These are generalized calculations with slight adjustment for gamified controls. So I'm going to take this, and we're just going to break our 3 vector, and we're going to do that for both of these. And we're going to use a function here inside of Unreal that's going to calculate the distance 2D. And so this gets a 2 vector and a 2 vector. We're just going to split these so we can get the x and y from this one and the x and y from this one. And then we're going to calculate the distance between the target z and our current z. It's going to get us a z offset. So we're going to take these and do different things with them. For the return value for the distance between the x, y, we're going to use a multiply. We're going to take this and we're going to multiply it by 490. 490 is basically half of gravity. So if gravity is 9.8 meters per second, 980 centimeters per second, this is half of that. So 1/2 of gravity, and then we're going to take this and we're going to get the square root. Going to need to leave ourselves a little bit more room. We're going to get the square root, and then we're going to multiply that by another number that we can calculate here in just a second. And then we're going to add that. Let's change this to a vector and a vector. So we're going to multiply that. When we add that to the separate vector, we're going to use that as our launch velocity. So what else are we going to throw in here? We're going to get the rotation that the player is going to have towards that orientation. So if we just have this this vector, it's going to get us the distance between them, but we can take the look at rotation, find look at rotation of the player location to the target, and from there we can get the forward vector and the up vector, or we can just get any up vector, and we can use that to compound. When I take these two things separately, the look at rotation is going to be just a unit vector, so the forward vector is a unit vector and the up vector is a unit vector. Putting these together, I get a slightly larger representation of the magnitude of the size of the direction that we're going. This is going to be what we're going to multiply up here. And then this z offset is going to allow us to have a displacement. We can plug this in here, and if we want, we can add another z over here, and we can just make an additional offset here. And we'll call that z offset. So this z offset that we're going to use is going to take into account how high the target is, and then we're going to be able to make adjustments if it's a particularly large gap. This is in lieu of having more precise mathematics going on here. So a start position and end position, the distance xy times half gravity, the square root of that, times the up vector plus the forward vector from the look at rotation, and then we're going to add to that the z value of our vertical offset. So with this, I should be able to, if things went right, take this pad. I need to put the collision back down. All right. So if I have this done correctly, I should be able to take the pad, put it over some distance. Make sure that's on the ground. Yep. And then we're going to take the target from this one, and I'm going to move it so that it's on this one, and it'll take the target for this one, and we'll move it back. So if I walk into this one, it should launch my character just a little short, and that's because where the player was when they contacted it was on the ground, and when I step up, the launch pad is actually elevated. The center of that is actually about 20 units up. So I'll just take this float value, and we'll make that instance editable. And for this one, we'll change the z offset to 20 and see if that fixes it. Yep, almost exactly landed on it. These are pretty small targets as well. And then, let's see, I guess it'd be 20, 25 would probably be the offset. We'll go 30 for good measure. Do that on both of these, and it should ping pong me back and forth between them. and I'll show you how this can work in a larger scale platforming environment. So this is going to be able to launch the player. I guess if I fight against the movement, it'll slow me down. But I can take these. Let's take this actor up, and for this one, I'll take the target and move it up as well. And then I can take this actor and we'll move it up here. And then for this one, we'll take the target and make it somewhere over here. We'll put a little cube underneath it. See if I can hit that pretty precisely. All right. So walking into this, I can bounce the character. Oh, I think I hit that ceiling right there. And overshot. Poor level design construction. All right, let's reimagine this with a slight offset then. Let's take this one asset. Oh, that's what had happened. Is I duplicated this within within the context of this asset. All right, let's plan this a little bit differently. We're going to flip this around, rotate it here, and then we're going to move this up to there, rotate that around, move that up to there, and then rotate that around, and then we shouldn't have any collision issues. And let's try this again. You can see with pretty good consistency, we're getting there. And if I took these and made the vertical offset on this a little bit higher, then it would probably launch us to the spot that we needed. There you go. And so with this math and a little bit of finagling, probably a little bit more generous landing platforms and launch distances, you can create a complex bounce pattern and launch pads that will send you exactly where you need the player to be. Hope this will let you go out there and keep building.